2, Coordinate Geometry of the Circle, Past Paper Question, January 2009, Question 6. So in part A of this question, we need to complete the square on this equation of a circle to find the centre and the radius of the circle. So the equation that we're given is x squared plus y squared minus 6x plus 4y equals 12. Rearranging this so that the x values and the y values are together gives us x squared minus 6x plus y squared plus 4y equals 12. Completing the square on x and completing the square on y gives us x minus 3 squared minus 3 squared plus y plus 2 squared minus 2 squared equals 12. Gathering these two numbers together and taking them to the end gives me x minus 3 squared plus y plus 2 squared minus 9 minus 4 equals 12. These come together to give me minus 13. Taking them over to the other side gives me the equation of the circle x minus 3 squared plus y plus 2 squared equals 25. That means using x minus a squared plus y minus b squared equals 25 equals r squared, where r equals the radius and the centre of the circle is at A, B, we can get that the centre of this circle is at 3 minus 2 and the radius is 5, as we have to take the positive square root of r squared. So the main piece of information that we got from part A was that the centre of the circle is at 3 minus 2, the radius is equal to 5, and the Cartesian equation of the circle is of the form x minus 3 squared plus y plus 2 squared equals 25. So that's the main piece of information that we got from part A. Moving on to part B, we have the point P, which is minus 1, 1, and the point Q, which is 7, minus 5. And we're told that both of these lie on the line C, which is this. So we need to show that PQ, which is the length P from point P to Q, is the diameter of C. Now from GCSE, we know that the diameter of a circle is equal to 2 times the radius. The radius in this case is 5, so 2 times 5, so the diameter is equal to 10. So back to core 1, we can find the length of PQ by doing the square root of x2 minus x1 squared plus y2 minus y1 squared. So substituting in the values we're given for point P and the point Q, we'll have 7 minus minus 1 squared plus minus 5 minus 1 squared, all square rooted. So 7 minus minus 1 gives me 8. 8 squared gives me 64. Minus 5 minus 1 gives me minus 6. Minus 6 squared gives me plus 36. And all of that will be square rooted. 64 plus 36 gives me 100. So the square root of 100, which is equal to 10. And because this is equal to 2r, we know that this is equal to the diameter of the circle. So moving on to part C, I think the easiest thing to do here is to draw a diagram of the circle. So here is my circle, and here is my y-axis, because we're told that the point R lies on the positive y-axis and the angle PRQ equals 90. Now, if you can remember from the GCSE recap material, we were told that angles in a semicircle equal 90. So, if I draw on the point P and let's say the point Q and draw a line between them, and then go to the edge of the semicircle, come back down to the other point in in both directions, bearing in mind that angles in the semicircle, as I said, give a 90-degree angle. So there's a 90-degree angle and there's a 90-degree angle. That means that R can either be here or R can be down here. So when the line crosses the y-axis, at the point where it crosses the axis, we have at the point where we cross the y-axis, we have x is equal to 0. So substituting that into the equation of the circle that we found in part A will give us 0 minus 3 squared plus y, which in this case now is r y plus 2 squared equals 25. So multiplying this out, minus 3 squared gives me 9 plus my y coordinate for r plus 2 squared equal to 25, which means that my y coordinate for r plus 2 squared will be equal to 16, moving my 9 over to the other side, and that gives me r y plus 2 will equal plus or minus 4. Moving my 2 over to the other side gives me r y equal to minus 2 plus or minus 4. So that gives me r y equals minus 6 or r y equals 2. But in the question, we're told that r lies on the positive y-axis. That means that the equation of, the point R must be at 0, 2. So we have to take our positive answer because R, Y must be greater than 0.